Hi all, welcome to Cyber Warfare Labs AWS Cloud Red Team course. In this module, we will discuss about how we can misuse or how we can use the functionality of VPS to literally move within the AWS cloud environment. So how we can literally move, or how we can perform the pivoting from one VPC to another VPC. So there may be some case where is some resources just like RDS or some services which is can only be accessible of some VPC because they are the critical services, they can't expose to the public audience. So how we can access those services which can only be accessed through some restricted IPs or restricted VPCs. So in this case we will discuss about how we exploit or how we perform a red teaming phase that's called a lateral movement or pivoting within the AWS environment. So how we can access the resources which is not accessible by any other VPC or any other IP address, but to exploit it to create a pivoting point, how we can access those services. Let's discuss. So you can see here in this diagram what we are going to perform. First we will discuss about what is lateral movement and what is pivoting and how we can misuse VPC or how we can use the functionality of VPC to perform lateral movement or pivoting within the AWS environment. So you can see here in this diagram we have three VPC. This is VPC 1, this is VPC 2, and this is VPC 3. Now the thing which we already discussed, that VPC is a virtual private cloud. That means it's a isolated network. So you can see here we can't access anything within there in VPC 1 from VPC B or VPC C. So that means whatever resources, whatever instances there in VPC A can only be accessible within the VPC A. How we can access? So there may be a case where we have resources in VPC B and these resources we want to access from VPC A. How it's possible? To make it possible, we have to create this VPC peering. VPC peering can only be done within two VPC. So here you can see here we have a VPC peering for VPC A to VPC B. So that means if you are there in VPC A, you can access the resources on VPC B. Second thing is there may be a case that VPC A may be having region 1. This is region 1 in AWS. Maybe this is have a region 1 US East A 1, sorry, US East 1, and this may be US West 1 or US West 2 or any other region. So this is region A and this is region B. Still we can access the VPC using this VPC peering techniques. So VPC peerings allow us to access VPC A or VPC B. So this is how we can perform. So peering will allow resources within one VPC to accessible using another VPCs. So this is called VPC peering. In this scenario, suppose we have three VPC. So there is VPC peering connection is established between VPC A and VPC B. You can see here, and it's a bidirectional connections. That means resources within VPC A can access the resources within VPC B, and vice versa also. If resource in VPC B can access the resources in VPC A. Second thing, we have a VPC C also. So you can see here we have a peering connections between VPC B and VPC C. So this is also have a peering connections. So you can see here we also connected VPC B to VPC C using this VPC peering. That means we can access the resources from VPC B to VPC C as well as VPC C to VPC B. But there is no VPC peering is established between VPC A and VPC C. There is no VPC connection established. So that means if there is a resources in VPC A cannot access the resources in VPC B. You can see here there is scenario VPC A can access VPC B, VPC B access VPC C, but VPC A cannot access VPC C directly. because there is no VPC peering connection is established here. So this is really important when you're performing a red teaming activity. So how we can access a VPC-C using VPC-A? You can see here in the scenario. First we'll discuss about lateral movement. So you can see here, if you have a VPC-B and you have a VPC-A and there is peering connection between VPC-A and VPC-B, you can access laterally movement. That means if you have in VPC-A one EC2 instance in VPC-A, this is the EC2 instance you have, and there is one more EC2 instance in VPC-B, you can only access the B instance using this A instance. So that's called a lateral movement. Lateral movement means you are moving your access from VPC-A to VPC-B like that. This is called lateral movement. You can still access VPC-B to VPC-C through this lateral movement techniques. But if you want to access VPC-A and VPC-C, you have to perform a pivoting techniques. Why? Because you have to create B point as a pivot point. So in this scenario, this will be your pivot point, or this hop will be your pivot hop. So this is how you can perform the pivoting. So suppose first you have to access the B, you have to create a pivoting point. That means whatever traffic coming to B will be redirected to traffic C, because B can access the C. So in this case, you can see here, this is a line I wrote, draw it. You can see here, this is the case we can perform the pivoting. So this is the difference between how we can perform a lateral movement and how we can perform the pivoting within AWS cloud environment using that functionality of virtual private clouds or VPC. So let's discuss practically how we can perform a lateral movement, how we can access the resources or instances within one VPC to another VPC, and how we can find out how the VPC peering is happen, which VPC have peered to how many VPCs, and how this connection is happen. So let's discuss. So I'm going to show you a practical demonstration how it works. Okay, so you can see here we have a 3 VPC. Let's do this thing. First, I configured the CLI. You can see here I already configured my CLI, which I have a read-only user right with few users right, few rights I only needed to access the EC2 instance or any instances within the VPCs. So let's discuss how we can do that. So first, what I'm going to check. First, I'm going to check the VPC peering connections. That will understand us that how the peering between two VPCs there, and one VPC have how many peering connections there. So that will describe all the peering connection in AWS instance. So you can see here, I just copy this one. Okay, so you can see here what command I executed. AWS EC2 describe VPC peering connections. So that will be describe all the peering connections there within the VPCs. You can see here this is really important to understand. This is the peering connections. One is acceptor info and another one is requester info. That means if this VPC request for this VPC for a peering connection, this will become an acceptor VPC and this will become a requester VPC. But connection will be bidirectional. That means you can access from this VPC to this VPC or this VPC to this VPC. You can see here this is the CIDR block. That means this is the second VPC and this is the first VPC. This is also there in US East 2 and this is also there in US East 2. This is the VPC ID and all this information you can see here. So this is how you can understand about how VPC peering is happen within the AWS environment. You can see here when we're looking for the tag that is mentioned that VPC1 to VPC2. So this is the VPC1 and this is the VPC2. So this is the first connection. You can see here in the diagram also we have a peering connection for VPC-A to VPC-B. Okay, now let's check another VPC. Is there any another VPC peering is there? Yes. You can see here this is the second VPC peering status. This is the acceptor and this is the requester. That means this is the same one which is there in top. This is the same one. That means there is a peering connection from VPC 2 to VPC 3, and this is the VPC peering connection ID. This is ID also there. When you check for the routing table, you understand about where this VPC peering this routing route is there. So you can see here when you're looking for the tags, you can see here this is the VPC 2 to VPC 3. You can see here there is a connection between VPC A to VPC B and VPC B to VPC C. There is no connection from VPC A to VPC C. Okay, so you can see here there is only 2 peering connections there in this VPC. Okay, now what next? How we understand about there is 2 VPC peering connections there. So that means suppose there is a scenario in this VPC. This is a public VPC. That means or public subnet. That means there is one web server is hosting. You get access in this VPC or this EC2 instance which is running there in this VPC using RC or any other methods. Now, if you are here in this VPC, if you want to access VPC C, how you can access it? So you have to understand about first peering connection, that you have to access VPC A to VPC B, then you have to access VPC B to VPC C. This is how called pivoting, and how when you accessing VPC A to VPC B, this is called lateral movement. You are moving laterally within the AWS environment. So from this command, I understood that there is 2 VPC peering connection, VPC A to VPC B and VPC B to VPC C. Now what next? So second thing which we are going to check is subnet. This is really important about the subnet, because why? This is a scenario. Suppose there is one VPC and there is 2 subnet. You can see here, if there is one VPC, there is a 2 subnet. There may be a case that only one subnet can access this VPC B, not the other one. Why? Because all the peering connection and all the routing is happening through routing table, and routing table can be attached at a subnet level. So there may be a chance that if there is a 2 subnet, one subnet cannot access VPC B, but other one can access it. So this is how it's really important to understand about the subnet. Still there is a peering from VPC A to VPC B, but you can't access it because if there is no routing table attached to your subnet for VPC B, you can't access it. Let's discuss. So you can see here the second what we are going to do, we are describing the subnet within the VPCs. Okay, let's copy this one and just open a new tab, paste it here. Now what you have to specify the VPC ID. So you can see here first what we are going to do. I'm exploring about VPC 1. So this is the VPC 2. This is the VPC 2. This is the VPC 2 and the below one, bottom one is VPC. This is the VPC 2 and this is the VPC 1. So there is VPC ID. So this is the VPC 1. Let's explore this VPC. This is the CIDR block and this is the VPC ID. Just copy the VPC ID, paste it here. How many subnets are there in this VPC? So you can see here there is 2 subnets there in this VPC. This is the first subnet and this is the subnet first, because you can see here in the tag subnet 1 VPC 1, and this is the second subnet. This is the second subnet. You can also see the CIDR 10.1.1.024. This is 10.1.2.024. So that we understood that there is one VPC1 which have a peering connection to VPC2, but we don't know it's attached to subnet level or VPC level. So let's explore. So there is two subnets. Now what next? So if you have idea about VPC, you have idea about peering, and now we understood about how subnets are there, how many subnets are there. What next? This is really important to understand about routing tables, because routing table is attached with VPC but associated with subnet level. So we have to check routing table, how this route is defined. Then after we can understand that which subnet can access the VPC2 and which cannot. Let's see. So open a new tab, paste it here. You have to specify the VPC ID. So same VPC ID I'm just copy from here. Okay, so this is the routing table which is associated with subnet, this subnet. So you can see here subnet in this VPC, and this is the subnet ID. You can see here this is a subnet 54. Okay, this one. So this is a subnet this routing table is associated with. This is the route information. You can see here this is the local within the VPC routing information. You can see here this is a PCX. PCX means there is a peering connections, where you can see here this is the IP which is denoted here to VPC2. So this is how you can understand that routing table which is associated with this subnet, that means subnet 2 can access the VPC2. This is the subnet 2 in VPC1 can access the sub VPC2. What about the another routing table? So you can see this is a R2 which is associated with VPC1, attached with VPC1 but associated with this subnet. There may be a case that this routing table can be associated with another subnet also, but you can see there is one more routing table which is associated with another subnet. This is a subnet, this routing table is associated. And what about our route information? So you can see here this is the local routing table, route, and this is the internet. So internet gateway attached to it. So it seems like this is the public subnet. The first one is this one is the private subnet. Only net gateway attached to it, but seems like this is the private subnet. This is the public subnet. You can't access VPC2 using this subnet or instances resource there in this subnet, but you can access the VPC2 from this subnet, because routing table attached to this subnet showing that, and route is defined that if any connection or any IP address which is belongs to this range going through this routing table, VPCX, that's peering connections routing tables. So this is how we understand about how does it work and how we can access it. Let's see. Now there is only two routing tables are there. One is attached to VPC 1 and subnet 1, and one is attached to subnet 2 within the same VPC. We are discussing about VPC 1. What next? We understood that here, you can see here from this diagram, we understood that there is two subnet. One is public subnet, one is private subnet. Only private subnet can access VPC-B. There is only peering connection. Why? Because routing table is attached to private subnet, which saying that you can access the VPC-B from private subnet itself. So there may be a chance if you get the RCE or remote code execution in public subnet, somehow you have to laterally move from private subnet to public subnet to private subnet, and then you have to perform lateral movement from private subnet to this VPC-B. So this is how it's really important, and it's really have a really weightage in our red teaming activities, Why? Because we can access, we have to understand about how we can access the resources, which IP it's restricted to access those resources. So this is how you can understand. Second thing, let's discuss about the same routing table or subnet. Let's discuss about the same subnet within VPC2. So we discuss about we discuss about VPC1, but let's discuss about VPC2. So what we are going to explain here, you can see here, I'll just describe the subnet filter, just copy this one. This is about VPC2, because we have to also understand about if we can access the VPC2 from subnet second, that means private subnet, there may be a chance that in VPC2 there is multiple subnet and routing table is not attached to that subnet where this critical data is there. So let's explore about VPC2. This is the VPC ID of VPC2. This is the VPC ID of VPC2. Okay, so here also we have a two subnet. You can see here also we have a two subnet. This is the first subnet, this is the second subnet. This is the 1 minute. This is showing for VPC1 only. Let me check the VPC ID is correct or not. Let's copy the VPC ID for this subnet. Yeah, this is the VPC 2D. 4D, sorry. This is a 4D. Yes, this is the 4D. Let's check what is there. No, it's there. So let's clean this one. Let's change. This is the VPC ID of first. That's why it's in copy. This is the second. Yeah. Okay, so you can see here when you're looking for the CIDR block 10.2. That means it's specified to VPC2, and 2.0 means second subnet, and 2.1 that means this is the first subnet. So there's also two subnet there in VPC2. Yeah, perfect. Now we have to discuss about the routing table, same we discussed in VPC1. Let's copy this one. Let's copy this one, open a new tab, paste it here, copy the VPC2 VPC ID here and paste it here. Okay, so you can see here, this is the routing table, this is the routing table ID which is associated with both the subnet. This routing table is associated with this subnet as well as this subnet. That means there are two subnet and there is only single routing table which is associated with both the subnet. This is not the case in VPC1. VPC1 we have two routing table. First it's associated with subnet 1 and another one is associated with subnet 2. Here we have a single routing table which is associated with both the subnet. Okay, and you can see here what route is defined. So you can see here VPC2 we have this is the local route information. This is this is the PCX 10.1.0.0. that means this is the peering connections. So you can access the 10.1.0.0 from both the subnet, and this is the peering connection. This is the local, and there is one more peering connections from 2 to 3. You can see here that the image I discussed. So in this VPCB we have two peering connection. One is VPC-A to VPC-B and another one is VPC-B to VPC-C. So this is how you can understand and you can perform a further lateral movement from VPC-B to VPC-C. So this is how it's important for a red teaming activities. Okay, so you can see here we can access both the subnets from our VPC1 private subnet. So let's how we can do all these things. We have to check. Okay, so what next? We understood that we can access VPC-A private subnet to VPC-B, and from VPC-B we can access the VPC-C. So first we have to how we can gain access to public subnet within the VPCA, then how we can literally move from public subnet to private subnet. One more questions, there is by default there is no restrictions. If you have multiple subnet, there is no need to define any route. By default there is one route, so you can access one subnet to another subnet, and whatever subnet is there you can by default access each and every subnets within the VPC. But to access another VPC you have these peering connections. So let's see how we can discuss it, but how we can perform this lateral movement or pivoting. So suppose if we got a access key, or we got a we can say RC or any public subnet which is hosting a web server or a web applications. So first let's discuss about if there are any instance within this VPC, because this is also important. EC2 instance is there or not. So let's copy this one, open a new tab, paste it here, and here you have to specify the subnet. So you can see here in this VPC, I'm talking about VPC1 because we are moving from VPC1 to VPC2. So this is the case where we describe about subnet. Okay, so you can see here this is the VPC subnet second and this is the subnet first. So let's check about public subnet, because public subnet is one we can directly access. We can't access private subnet. This is also important. Even if you have a access key or ID, you can't access private subnet. To access the private subnet, you have to first access the public subnet, then only you can access the private subnet. So this is also important to perform a red teaming activities. So you can see here, I just copy this subnet ID. This is a public subnet. Why this is public? But when you check the routing table, you can see here there is one route. This is a route which is saying it's internet gateway. IGW, that means if it's a public subnet, because if internet gateway is attached to it, this is the public subnet. Let's discuss about when we're looking for a EC2 instance. Let's copy this subnet and paste it here. So I'm just looking for all the instance within this subnet, public subnet. So you can see here, this is a image ID, this is the instance ID. This is the public IP which is associated with this instance, and this is the private IP. So to access the instance, you definitely need a public ID, public IP address. All the information which is regarding this EC2 instance, you can see here, public IP, EBS attached to this one, what are the role which is attached to this one, all these things you can check it here. The private IP, public IP associated with this one. So this is also important. Key, tag which is associated with this one. So all this information you can check about this, instance. So let's see. Okay, so there is only single instance there in this subnet, which is there in VPC1, but subnet in public subnet. So this is a public IP address. So let's suppose during the credential access phase, you found a valid credential or a key to access this instance, you can access it. So suppose I already have the key. Suppose you found the key of SSH key of this EC2 instance, and you have a key as well as this public IP, you can access it. So let's load this one. You can see here, this is the IP which is associated with this subnet. I'm going to access this. Perfect. So that means it's so you can access through a if you have a key, or if you have a any credentials, or you can also there is a case where suppose red teamers got an initial access using RC. Suppose this EC2 instance which is hosting a web application, and you found that RC, you can access this instance. So there is multiple way to getting the initial access, but suppose if you have a key or if you have RC, you got the initial access in this public instance. Okay, let's check. So this is all. So you got the initial access on public instance. Okay, let's see if there is any instance within the another subnet. This is, we discuss about the public subnet. Let's check about the private subnet. Let's copy this one. So there is only single instance in public subnet. Let's copy this one, paste it here, and VPC1, I'm here in VPC1. This is the VPC1 subnet ID. So I specify this is a 10.1.1.1 public subnet. I already specify. I saw there is one EC2 instance. I got access, initial access on those instance. This instance. Now this is the private subnet. So let's copy this subnet ID. And this is the subnet ID. Okay, so there is one instance within the private subnet, and this is the, because there is no public IP attached to this this instance, only private IP is there. You can see here there is only private IP associated with this one. So this is a private IP, which is, you can see here using this IP address, it's indicate that this is a part of second subnet or private subnet. This is the one case you can access public subnet to from public subnet, or the instance within the public subnet to instance within the private subnet. Why? Because we know that from private subnet we can access the VPC2 or whatever instance they are in VPC2. So this is important. Okay, let's check what about the, if is there any instance in VPC2. Let's open a new tab. Let's copy the same one, describe instance. Let's copy this one. Now let's not specify the subnet ID, just check using VPC ID. So I'm just looking how many instances are there in second VPC. So this is about the VPC. This is the VPC ID of first VPC. This is VPC ID of first VPC. This is the VPC ID of second VPC. Let's copy this one. You have to check the CIDR block. So let's copy this one, paste it here. Okay, so you can see here that there is one instance. There is no public IP associated with this one. There is no public IP. There is only private IP, which is this one. And you can see here this IP address seems like it belongs to a VPC2. So one more question, because we checked that the routing table in VPC2 and we found that both the subnet have the same routing table, and that means you from private subnet you can only from VPC1 private subnet you can access VPC2 instances. Let's check, can we access? Let's copy this one, and we got the initial access. Let's check, can we access private subnet, that means VPC2, from VPC1 public subnet, because this is should not be there. Let's see, we can access it. So you can see here there is no connections, because there is no directly connection, no route is defined. Only route is defined from VPC1 private subnet to VPC2. You can't access it. So how we can access it? How we can perform this lateral movement? So that means if you are in the, if you are here, if you are in public subnet, you go to the initial access. First you have to find out the way how we can access the private subnet. So just like we did, this is the subnet ID, and we found that this is for public subnet, the second one is for private subnet. Let's first access this one. So suppose we already compromise a key and we specify this IP address 10.1.2.173. This 10.1.1.114, this means we have instance in VPC1 public subnet, and we are going to access 10.1.2.173. That means in the same VPC but in another subnet, private subnet. Let's copy this, let's check, can we access it? Yes. You can see here currently we have a shell of private, subnet instance, the instance which is there in private subnet. Now we know that from private subnet you can access the VPC2. So suppose this is the instance, this is the IP address of instance within in VPC2. Can we access it? So suppose this is the key I found using a credential access phase. So this is also important. Credential access is also important to grab the key credentials once you have this initial access within the environments, and how we can literally move. This is the second case. So suppose this is the VPC2. You can see here 10.2.1.191. We are accessing from 10.1.2.173. Let's see, can we access it? And that's all. You can access VPC2 instance from VPC1 private subnet. Why? Because the routing table is only attached, associated with private subnet. If it's associated with public subnet, you can access from the public subnet itself. So this is how you can perform a lateral movement. Same like when you check if you have access to VPC3, how we can make a pivoting point for VPC2, and how we can perform the pivoting to access the VPC3. So this is all about how we can perform the lateral movement and pivoting, but this is really important to understand the difference between lateral movement and pivoting. In pivoting, we have to create one hop, which is called a pivot hop, which is forward our traffic from here to here and in both the directions. So this is how you can perform the pivoting. To doing all these things, you should enumerate first about the here we discussed about EC2 instances, but there's a lot more thing is there. You have to enumerate about is there any RDS instance, is there any functions defined in the same VPC, because now these days private VPCs is coming into market, because organization or companies moving to the clouds and they want their data to be protected. So that's why they use these isolated environments, and where they have a critical data in private VPC. So how we can literally, just like we doing in red teaming in on-prem environment, to access one VLAN to another VLAN, how we can move from one VPC to another VPC. This is how you can perform a lateral movement or pivoting techniques. So that's all for this video. Thank you so much for watching this video. Thank you.